Hi folks, I'm Bill Vales. On this Fun with Science, we are featuring the Littleton Robotics Team 6328 Mechanical Advantage. In our first show, we covered the building of the robot, starting with organizing and building the team, idea conception, breakdown of work, and the implementation of tasks resulting in the building of a robot. In this show, we cover the strategy used to scout and rank the competition of the other teams and other robots. We then take a look at what is involved with the programming and operation of the robot. Finally, we look at the operational strategies used on the field of play. And then we look at some actual competition on game day.
Welcome to the 2019 First Row Robotics Competition and this year's game, Destination Deep Space, presented by the Boeing Company. Two alliances of deep space travelers race to place hatch panels on their rockets and cargo ship, load valuable cargo for transport off the planet, and return to the safety of their habitat, all before the next sandstorm sweeps through. Alliances earn points for exiting the habitat, securing hatch panels, and any cargo that's properly stored. The alliance that earns the most points wins the match.
I'm in the programming room now with Elliot, Hunter, and Abby, and this is where they do programming. Who wants to give me a thumbnail of what it is you actually do?
So we program the code for the robot, and we program things like the subsystems and the OI board. So,
Okay, so what do you mean by a subsystem?
like the subsystems, like the arm and the vacuum, which controls things like the beaver tail.
Okay, so the arm would be one subsystem?
Yes, the arm would be one subsystem.
Okay, and the beaver tail? So that must mean you have something that's going to flip something up?
Well, that's what we use to grab onto the hab level, the third hab level, which is the highest.
Okay.
And yeah.
Okay. What kind of programming language do you use?
We use Java for the main robot. And anything?
Yes, so some of the secondary vision processing code and driver station code is written in Python.
Okay. What makes you choose Java versus Python? Or
So officially for the main robot code, the three supported languages are C++, Java, and LabVIEW. Java is the most widely used, so it generally has the most support, and it's LabVIEW is fairly different than the other two and is not something we have much familiarity with. So we ended up choosing Java for that. But Python makes doing some of the other development easier.
Yeah.
And while it's not necessarily as fast for the things we're using it for, it doesn't matter.
Yeah. Do you program, Abby, in these languages?
Yeah, this is my first year on the team, but
Okay.
I'm helping with, I get like some smaller assignments to help with. I've done some of the helping with subsystems and commands.
Okay, and what languages do you program in?
I program in Java.
In Java. Have you folks ever thought of getting like a job for $80,000 or $90,000 a year, something like that? It's probably in your future. How much code would you say is for, let's say, an ARM subsystem? You know, how much?
A lot.
Now, if I was a manager, I'd want a better answer than a lot. I mean, how long would it take you to write a piece of code like that? How large would it be in terms of lines of code?
So
I know that's not a great metric, but
the ARM is actually one of the most complicated pieces of code because there's three core moving parts plus the shoulder joint, which is only 2 positions. And then there's a number of limits that have to be enforced in software, including the fact that the rules state that the robot can't ever extend more than 30 inches outside its frame perimeter. And in some angles, it would be possible for the arm to extend outside of that. So the software has to be calculating how far outside the frame perimeter it is all the time and limiting its extension to keep it within that limit.
I see. And those are rules given by the rules committee
that rule is.
I see.
There's other limits, like if we have the arm at certain angles, we can't be lowering the shoulder because we'd smash the arm into the ground.
Okay.
So the code has to detect that would happen and then delay lowering the arm until it's at an angle where it's safe to do so.
Okay. So you must run into bugs like that. All of a sudden the arm has gone through a window or, gone down too low. Things like that. What are some of the bugs that you run into when you're doing some of these subsystems?
So that's actually one of the challenges for some of these subsystems, is that we can't really test them initially after we write them because we don't have access to the robot and the physical mechanisms that they're designed to control.
Okay.
So we haven't actually fully tested the ARM code yet because we don't have a fully assembled ARM quite yet.
I see.
We try and test on previous year's robots.
Mm-hmm.
As you've seen out in the other room, we have last year's robot out, and we've used old robots for a ton of testing every year.
Mm-hmm. Okay. Hunter, what languages do you program in?
I program in Java, and that's really it.
Okay. Are you going to learn Python?
Yeah, probably.
Yeah. How about you,
Hopefully.
Abby? Are you going to learn Python?
I don't know, probably.
I mean, there's a market
Yeah.
for that. There's a market for Python programmers. So, that's great. I see you have some code displayed here. What do you have here?
So this file right here is the ARM control code.
Oh,
So the part that's on the screen right now is mostly just initial setup that happens when you power the robot on to configure the motor controllers with all the proper settings. Because there's all sorts of things that you can configure on our motor controllers since they're smart motor controllers. And there's a lot of useful features, but you have to set them up. And then this down here is some of the code that runs constantly to check limits, and like I described earlier.
mm-hmm. And you can do all this on your laptops? Those are your programming? That's what you're programming on, your laptop?
Yeah, this is just my laptop, and I have it plugged into a screen here.
Yeah, great. Okay, we've just left the programming room, and now we're out in the, what do you call this room?
The driving area?
Okay, the driving area. You don't seem sure about the name of the room, but that's okay. Okay, we'll call it the driving area. What's all this over here, Elliot?
So this is the operator console that we use to control the robot. So we have a Windows tablet here running the driver station's control software.
Okay.
Then we have two joysticks for the driver to drive the robot around
Okay.
and the other controls that they
Okay.
need. And then all the other systems are controlled by that custom panel over there, which has a small joystick for moving this elevator up and down, a number of buttons, many of which have LED indicators, and then along the top are some override switches that we don't need in matches, but that are useful at other times. For example, there's one that says drive disable, so that when we have it on a cart in the pit, we don't accidentally bump joystick and make it drive off the cart.
Okay. Now, when you're in competition, this is your control panel, is that correct?
Yes, we take it onto the field, and then we plug in a wire from the field into it, and then this is what we use to control the robot.
Okay. Is one person operating this or two people?
Two people.
Two people, so one person over on that panel
Yep.
on the right and one person here.
Yep.
Okay, this is talking to me. These seem like they have a personality. What's this one's name?
This is called Revenge of BotBot, or Revenge.
Okay, Revenge. So that was last year's.
Yes.
Okay. And you're nice enough, number of people here did a little reprogramming, moved some things around, and you're going to show us how to, what this does to remind us. Now, this was moved out of the way. And I noticed when it was moved out of the way, it was referred to with some sort of name. What was this name?
We call this one NotBot because it's just a drive base. It's not a full robot.
Okay. Is this going to be a full robot at some point?
Probably not. We occasionally mount a few things to it for testing, but at this point it's basically just a test bed machine.
Okay. Should I feel sad for it that it's not going to be a robot?
You can.
Okay, I will. Okay, so BotBot, right?
Revenge of BotBot.
Revenge of BotBot. Okay. Show us some stuff.
So the primary objective in this game was to take these power cubes and then put them in the scale and the switch, which were these balances on the field. So Revenge has an intake here that sucks them in, and then an elevator mechanism that can lift them up, and then the intake can spit them back out.
Okay.
So first I'll fold the intake down, and then we drive over to the cube. And then all we have to do is run the intake. And normally there'd be two people here, so one person would drive into it while the other person would run
Do you
the
want
intake.
me to hold that for you?
Yes, please. There we go.
Wow.
And now we can lift it up. And then we'd go somewhere with it.
Okay.
And then we could
Come over to me.
spit it back out. Unfortunately, there's enough wear on it that it has trouble holding. And then I'll just have it spit out at a low power.
Okay. Well, I remember when we taped this last year when we looked at again, this is BotBot.
Revenge of BotBot.
This is Revenge of BotBot. When we watched, is this what we saw last year, or was this in the bag when we came here last year? You had something in the bag.
Yeah, then it would have been.
Okay, so this was in the bag. Well, you had something else here, and boy, that thing just moved around at a tremendous rate of speed. And from watching the competition, these things really move.
Yeah.
I mean, you have a certain amount of time, I take it?
Each match is 2.5 minutes.
Okay. And you have to do so many tasks in that 2.5 minutes?
Well, it's not that you have to do a particular number of tasks. It's just that for each task you complete, you get points. So you want to do as many as you can.
Okay.
And
okay.
that, because you win the match by getting as many points as you can if you can get more than the other alliance.
Okay, I see. Okay, I'm here with Jonah now, and Jonah, we're going to talk about scouting. That's one of the roles that you play, I take it. So tell us a little what scouting is.
So scouting is another branch of what we do at competitions. So we have a team of people that sit in the stands whose entire job is to watch matches, and then they gather data on all of the other teams. We then do data analysis. Now, the key reason we have to do that is the second part of the competition is an elimination tournament, and that's played in alliances. There's a process where teams have to select who is going to play on their alliance, so we need data on the other teams in order to make the best choice.
Okay, okay. What grade are you in?
I'm in 8th grade.
You're in the 8th grade. How do you collect the data? How do you collect the data?
So we have two systems. One of them, which is the system we're currently using, uses sheets of paper. So it's sort of like a standardized test where you fill in bubbles that represent the data, so like how many of a particular object they've scored.
I see.
Then at events, we have a scanner, so we take the sheets and that goes into a database so that we can do all of our analysis.
I see, I see. So on the attributes on your paper, there's various attributes about the competition's robots?
Yes.
How it does things and...
Yeah. So most of it is about how many of a given object they scored. So for example, last year it would be how many of the power cubes they were able to put in particular locations.
Okay.
There's also some more subjective information,
Yeah.
so like rating how well their intake performed for particular objects,
Okay.
or how efficient they were at driving across the field.
Okay. So that data gets put into some sort of spreadsheet or database tool?
Yeah.
And then what do you do with it? How do you evaluate the data at that point?
So in order to figure out who we want to be on our alliance for the elimination tournaments, we use predictive analysis. So the way that works is we look at all of the rounds that have been played, and we try and identify characteristics of the alliance that won, so that we can figure out what teams we should play with in order to maximize our chance of winning. The other thing we do with the data is generate coaches sheets. So those are given to the drive team behind our robot so that they have data on the teams they're playing against and with.
I see. How accurate empirically have you found your predictive analysis to be?
So this year, we can predict whether an alliance will win a match with about 75% accuracy.
Yeah.
But that may improve as we change our methods.
Yeah. Okay. You sure you're in 8th grade?
Yes.
Okay. Oh.
So when you get this, how do you always get the team you want? Like,
Oh,
the
good.
alliance, you know?
Good question from the camera crew. So you evaluate your data,
Yeah.
okay, and then you use that to select which team you'd like to form an alliance with.
Yes, exactly.
Okay. So how do you entice that team to to come over to your side?
So there's a whole official process for how alliances are determined. Throughout the competition, teams are ranked, and the top 8 teams participate in that selection. So broadly, the way it works is that teams that are in the top 8 request that other teams join their alliance, and generally teams will accept that invitation. And then we go through all of the different alliances, selecting teams one by one.
Okay, great. What a coherent explanation. I'm speechless. Great, wonderful description. Okay. Well, Deanna, this is our 3rd year that we've come to visit you, and every year I'm more amazed than the previous year. How much time do you and the other mentors put into this process?
So in the main season, so right now the building competition season, we have open work hours 7 days a week, Monday through Friday, 5:30 to 9, Saturdays 9 a.m. to 9 p.m., and then Sundays 11 a.m. to 8 p.m. We offer this schedule, so we know kids have a lot of other activities, so we want to have our workspace open so they can not feel like, oh, I can't be on robotics because I'm in play or I'm doing the sports. It's open time, so they can kind of come when they're available, and that I think encourages a lot of kids to join the team, which is what we want. So we do spend a fair amount of time. And then the off season, we have technical training meetings. Like this past off season, we held CAD training, machining training, programming training, scouting systems training. In addition, we have a really widespread community outreach program that we run in the spring, summer, and fall, where we go to different events like Third Thursday in Fay Park. We're actually headed to the Jackson Man Community Center in Alston on Wednesday to do a workshop for some students there. So we kind of go all over the place. So it really is a year-round activity.
Yeah, it sounds like a year-round activity. I mean, talking to some of these kids, the job that you do with them. I mean, you inspire them, you give them direction in their studies, I'm sure in their life. You have to feel pretty good about that.
Yeah, I mean, I'm like the proudest, happiest mentor ever.
Yeah.
Like when they say like, oh, I want to be an engineer, this has really inspired me. Like I always tear up, and it really does warm my heart. And like that's why I'm here. I had some really special mentors in high school that did that for me.
You did.
So I wanted to kind of give it back and do the same for the students that I work with.
Yeah, that's really great. I'm amazed. I look forward to seeing you at Third Thursday this year. And when will your competition, or have you already had the competition?
We had one of our
Okay.
3 so far in Salem, New Hampshire a couple weeks ago.
Okay.
We're headed out to Springfield in 2 weeks for our second one, and then our third one's in Shrewsbury the weekend after that.
Okay.
And from there, we can qualify for the New England District Championship, hopefully, and then hopefully World Championship after that as well.
Okay. You know, I'd really encourage people to watch these things in operation because it's competitive.
It's very competitive.
It's very competitive.
It's just like any sports team.
Yeah.
But the cool thing about it is that if your opponent breaks down in a match, you go over and help them fix their robot and get back up on the field. So that's the really cool thing about FIRST is like, okay, yes, you're competing against each other, but you're also there to support one another.
Yeah.
You want a fair match. You don't want to win because they were broken. You give them the parts they need to fix to get back on the
I
field.
see, and then beat them.
Yeah, and then beat them.
Yeah, right. Well, I want to thank you very much for letting us in here and take away from your design and engineering time.
Oh,
And,
thank you. We love having you guys here. It's
yeah,
really
that's
good
great.
outreach to the community to show a little bit what we're doing here.
Yeah, great. Well, and I hope that you, our viewers, have learned something about 6328. This is a growing program in our community, and that's 6328 Mechanical Advantage. And thank you so much. Right?
Thank you, Bill. Yeah, I got the numbers here.
Let's now take a look at the Littleton Robotics Team 6328 at a recent competition.
Now we're back in the tally-out time for match number 2. Moving from both sides of the field. 15-19 Mechanical Mayhem grabbing a piece of cargo for the Red Alliance. Mechanical Advantage placing a hatch panel. Time ticks away. 5, 4, 3, 2, 1. Robots in motion. We've got 1, 2, 3, 4, 5, 6 robots off the half. Hand manipulator. Off it goes. You can go either side, and boom, it just zeroes right in on the spot. Blue line's now up by 6. $72.66. Thinking about what they're going to do. Is the rain. Steam box. Ooh. They've got a vacuum system on the front of that thing with some pedals from a wheelchair. It's interesting to see the different parts that teams choose to use in the construction of their robots, things that they recycle. Blue Lines now, there goes Neutrons. They've got some more cargo. They're going to go for the high on the cargo there, rocket ship. They're going to fill in the high spot, so that's A line as they put those 67-31 now looking for a place to hang that hatch panel as the cargo ship is full. That's 30 seconds. Still plenty of time for Neutrons to finish this off. And there's a suction action 63-28. Wow. With the beaver tail, it latches right onto the smooth.
Wow. What a process. From building a team, to idea conception, to robot build, programming and test, and then the actual competition. Building the robot is done in only 6.5 weeks. The competition has every bit of excitement as a sporting event. This entire process yields many benefits, from STEM knowledge to team building, new friendships, professional cooperation and competition, and how hard work and dedication yields positive results. The fruits of this work will be transitioned to future teams so they may benefit from past efforts. New teams will build on this work and return the favor to those teams that follow. The technical and collaboration skills will last a lifetime through career choices, higher education, and beyond. What a great program. Congratulations to Littleton Robotics Team 6328 Mechanical Advantage. We hope you have enjoyed these shows. See you next time.